Before I begin, it's worth mentioning that you need to be confident with finding the least common multiple of two numbers, substitution, and solving linear equations to be successful in this topic. I'm not going to recap them in this video as I want to keep it short, so I'll leave a link in the description if you need to revise these first. And there are different versions of this method, but I'm using this particular one because the steps are always the same. The elimination method hinges on the fact that if we get ourselves into the position where the number in front of both x's is the same, or the number in front of both y's is the same, we can simply subtract the two equations. 2x take away 2x is 0, 6y take away 2y is 4y, 10 take away is 5. So now we've got an equation that we can solve. And that's why it's called the elimination method. We've eliminated the x. 5x take away 2x is 3x, 6y take away 6y is nothing, and 20 take away 5 is 15. And again, we're left with an equation that we can solve. This time we've eliminated the y's. So now you know we need either both the x's or both the y's to be the same. How do we achieve this when the equation isn't already like that? It's quite simple. Decide whether you want the x's or the y's to be the same. It doesn't matter which. The y's look like they might be easier to work with here, but because it's a demonstration, I'm going to pick the x's. Having chosen x, I'm going to find the lowest common multiple of the x coefficients. The lowest common multiple is 12. So what I'm aiming for is for both x's to become 12x. And I always choose a positive. So I'm going to multiply each equation by the number that will get me to 12x. So I have to multiply the first equation by 4. So I get 3x times 4 is 12x. And I'm going to have to multiply the second equation by minus 3. Because minus 3 times minus 4x will give me the 12x. You can see I've achieved what I wanted. The x terms in each equation are the same. So now I can move on to the next step of subtracting the equations. 12x take away 12x is nothing. And I'm just going to stop here because this is actually the most dangerous step in the whole process. It's where you're most likely to go wrong. So I'm going to carefully write out the subtraction like this. I'm going to take the top value and subtract from it the bottom value. So I'm doing my working out very clearly. The top value is plus 12. The bottom value is minus 6. And this allows me to see clearly I'm subtracting a minus 6. I have a minus and a minus, so I can see this becomes a plus. So I'm left with plus 12 plus 6 to give me 18, positive 18. And it's the same here. I'm going to do the working out very carefully so I can't go wrong. I'm going to take the top number and subtract from it the bottom number. The top number is plus 24. The bottom number is minus 12. And so I can see the same thing here. I've got a minus and a minus to give me a plus. So it's plus 24 plus 12 to give me positive 36. And hopefully you can see how easily I could have gone wrong here if I didn't very carefully use this method. So now I have an equation that I can solve. So I found that y is equal to 2, but I still need to find x. I'm going to substitute this into either of the two original equations. I'm going to choose the top one because it looks straightforward. And again, I'm going to go ahead and solve. And so finally, I've got both values. x equal to 0 and y is equal to 2. One more example. So the first step is to decide whether you're going to pick the x's or the y's to be the same. Now, the x's look easiest here, but again, because it's a demonstration, I'm going to pick the y's. And so I want to find the least common multiple of the y coefficients. So I'm aiming for both equations to have 20y. So I need to multiply each equation by a number that will get the terms to 20y. So I'm going to have to multiply the first equation by minus 4 because minus 4 times minus 5 gives me the 20y, and the second equation by minus 5 because minus 5 times minus 4 gives me 20y. So I've got myself into the situation that I wanted. Both the y's are the same, so I can now go ahead and subtract. Minus 12x minus 20x. And again, this is a very dangerous step, so I'm going to carefully use this method. I'm going to take the number from the top equation and subtract from it the number on the bottom equation. So minus 12 is the value of the top, minus 20 the value on the bottom equation. I can see here I've got a minus and a minus, so this becomes a plus. So minus 12 plus 20 is going to give me 8. And hopefully again you can see how easily I could have gone wrong here. It's by far the most dangerous step in the whole process. Similar thing here. The number on the top subtract the number on the bottom. So the number on the top is minus 40 and the number on the bottom is minus 40. So this becomes a plus. Minus 40 add 40 results in 0. And again, I've arrived at a point where I have an equation now that I can solve. So the answer to the first part is x equals 0. I'm now going to substitute this into either of the original equations. And solve. And so I have my answers.